References for criteria and credits related to emergency reporting are shown here. Credits for emergency reporting, making up 30% of the total credit for communications, involves a review of available facilities for receipt and processing of alarms at Public Safety Answering Points, or PSAPs. The equipment used for receipt of incoming emergency calls accounts for 70% of the credit for emergency reporting. There are two recognized levels of service. The first is a system with either basic 911 or no 911 capabilities, and the second is an enhanced 911 system with various features which we will discuss later on in this presentation. A system with no 911 capabilities is obvious. Callers do not call 911 to reach telecommunicators at the PSAP. A system with basic 911 capabilities is not capable of receiving enhanced 911 calls. They do not have provisions for routing callers through emergency circuits to the proper PSAP. Instead, calls travel via commercial lines shared by everyone in the community, which are more subject to system loading during high volume events. In addition, basic 911 systems may or may not have capabilities such as automatic number identification, which allows the person answering the call to identify the phone number of the caller, or automatic location identifiers, which allows the person answering the phone to identify the physical location of the caller. Facilities having basic or no 911 capabilities can earn only 10% of the 3 points of credit available for emergency reporting. Facilities having enhanced 911 capabilities can earn 100% of the 3 points of credit available for emergency reporting. Enhanced 911 systems have consoles capable of receiving and managing 911 calls. These systems can receive multiple classes of service, including wireless, voice over Internet protocol, or regular landline calls. 911 calls made from landlines and originating from within the jurisdiction are correctly routed through dedicated circuits to the proper PSAP. For all classes of service, when the 911 call is answered at the PSAP, the caller's phone number, and in some cases the caller's location, is made known to the telecommunicator answering the call. This information is always verified so that emergency responders can be properly selected and routed to the caller's location. With an enhanced 911 system, there is usually a Geographical Information System, or GIS, map display that shows the caller's location. When callers use cell phones to call 911, the process becomes a little different. In communities where cell phone companies offer only Phase 1 services, the location of the cell tower that is being accessed by the caller is shown and plotted on the PSAP maps. This is referred to in the FSRS as wireless Phase 1 with static ALI functionality. Phase 2 systems will continue to ping the phone in the background until the actual GPS coordinates of the phone are determined. The caller's actual location is then shown on the PSAP data screens and GIS maps. This is referred to in the FSRS as wireless Phase 2 with dynamic ALI functionality. The Voice over Internet Protocol class of service also has two levels. Callers with this class of service are using devices such as MagicJack, Vonage, or similar portable phone interfaces. When they activate their equipment, they register the location of the device on a website. Problems arise when these users go to a different location, plug in their portable interface, and then need to make a 911 call. This is a real problem if they haven't changed their device's location on the system's website. In a system with static ALI functionality, the receiving PSAP's telecommunicator sees the registered location of the device and not the actual location of the caller. A nomadic system with dynamic ALI functionality is different. The caller's actual location is displayed on the telecommunicator's screens. With the various classes of servers callers can use to reach 911 PSAPs, you can see where the confusion may arise as to the caller's actual location. Because of this uncertainty, regardless of the class of service used to reach the PSAP, telecommunicators will query the caller to verify their address and phone number. The other 30% of the credits for emergency reporting come from availability and use of a CAD system, a computer-aided dispatch system, to categorize calls, identify required response units, and manage the status of resources in the field. There are several features associated with the CAD system. The first level of CAD is called Basic CAD. The Basic CAD system provides assistance in initiating calls for service, dispatching and maintaining status of responding resources in the field. This means that the software uses the alarm location and recommends the correct fire department to dispatch. It may also allow the dispatcher to record times related to apparatus or personnel dispatch, arrival, and departure from the alarm location, and to enter data related to the incident into a records management system. It may also allow the telecommunicators to record and monitor in or out of service status for each apparatus. In a basic CAD system, all of the data entries made by the telecommunicator are for use by the PSAP in managing the alarm response. A CAD system that has management information systems will automatically accept, display, and plot caller location data on a map display and access historical incident information related to the caller's address or phone number. A CAD system that has interoperability features allows the PSAP to electronically send information to responders or other PSAPs. This information can include the automatic number information, the automatic location information, historical information, and any notes the telecommunicator may make while managing the incident. CAD systems with GIS AVL capabilities are unique in that they maximize efficiency in dispatching and managing assets during an emergency event. To receive credit for this capability, all pumpers, ladder trucks, and service trucks must be equipped with tracking devices that allow the CAD system to continually track their locations. In addition, the CAD system must be able to recognize the apparatus location with respect to the alarm location, and to choose the closest in-service apparatus to respond. With this type of system, the telecommunicator creates the event and the CAD recommends a dispatch package that is based on the location, nature, and needs of the alarm. For instance, a typical alarm may require 2 engines and a service company to respond. In the background, the CAD system has been pinging the locations of assigned department apparatus, and based on in or out of service status of each apparatus, the CAD system recommends the 2 closest in-service pumpers and the closest in-service service company to respond to that alarm. If the building at that alarm's address is a tall building, the CAD may be pre-programmed to include the nearest ladder company as part of the recommended response package. Even with this capability, the telecommunicators retain the ability to accept, reject, or modify the CAD's recommendation when completing the dispatch. With this feature, once the alarm is dispatched, the CAD's GIS system has the capability of tracking and displaying on a map the locations of all responding apparatus with respect to the alarm location. As always, we at the Property Insurance Association hope this information has been useful to you. Please do not hesitate to call us should you have any questions or concerns about the contents of this presentation. Have a great day, and thank you for listening.